नॉक नॉक। कृपया लिव द कोड एक्सप्रेस में सवार सभी यात्रीगण ध्यान देवें। आप सभी के लिए अत्यंत आवश्यक सूचना। कहीं आपकी ट्रेन लिव द कोड एक्सप्रेस छूट न जाए। लिव द कोड एक्सप्रेस डे फॉर यू स्टेशन प्लेटफॉर्म नंबर 2 राइट 3/4 से चंद घंटों में छूटने वाली है, तो जल्द से जल्द अपने टिकट रजिस्ट्रेशन कर लेवें। The link for registration had been provided in the description box. कल्याण उत्सव का स्नेहिल आमंत्रण from Team Live the Code. Good evening to one and all present here. I am Sarika Purohit, sophomore at IIST College, and I'm glad to be host of today's session. We are thrilled to bring you an enthralling and enlightening session on future of career transition in AI/ML. It's an eminent pleasure of mine to introduce our today's speaker. He is none other than Mr. Prakhar Srivastava, sir. Sir secured analyst position at Deloitte, have won several national and technical business hackathons. Sir created their own startups and helps others to develop startups from ground zero. Now, without taking much time, I would like to invite Prakhar sir to please take our Live the Code Express to right destination. Over to you, Prakhar sir.
Hi guys. I hope I'm well. Audible? Can you let me know?
Yes, sir, you are audible.
Okay, great. So, hi guys. I am Prakhar Srivastava, as she mentioned before, and I'm mostly going to talk about ML, AI, and maybe some Marvel references and video game references, just to make you understand how to go about these things. This might get a little mathematical. I hope it does not. But at the same time, what I'm trying to do right now is going to make you understand, if you are in college right now, how should you approach your next 1 year or 2 years so that you can secure that analyst, data analyst, normal analyst, or a machine learning engineer position. Okay, so before we get started, I'll start sharing my screen because I want to share my presentation. Give me a second. Share screen. It should get on. If somebody can tell me if it's on. Is it on? I hope it is. Okay. Private chat, it's on. I hope it is on. Let me just check. Let me just check with someone if it's on. Give me a second. Right, it is on. Good, great. This is what I wanted to see. You might see some emails, but I'll try to hide them as much as I can, but you can't do much. Okay, so let's just get started from ground zero. I'm mostly going to talk about fast tracking your dev life in the sense that you're going to develop algorithms and stuff, things like that, machine learning algorithms, AI, data analysis, things like that. Okay, and how do you transition yourself into that? Even if you are doing a job right now, I am more than qualified to tell you how you can transition there, because that's something that I do on the regular. Just to give you a brief about myself. So I completed my engineering from BIT, Sindri, okay, and I graduated recently, okay, and I got through a position at Deloitte as a data analyst. But before that, before even going for a placement and things like that, I was out there creating software, a lot of machine learning software, a lot of software for other startups, a lot of software for private business owners, and I used to sell them. But at the same time, if you can see my screen, that's also written something in brackets. If you look at it, fast track your development journey, a short and fun presentation to help you get that awesome job while being a lazy engineer. And that's the point of emphasis that I keep. I do recognize myself as a lazy engineer, and I think most of the people do as well in colleges. So I do consider myself the lazy engineer who will do the bare minimum work that will get him to that position where he's very comfortable. I'm that one person. So I will do the bare minimum work to get that one perfect job, then I'll chill out. And then I'll see like what next I have to achieve, and then I'll do the bare minimum work to get there, and then I'll chill out. this way I have managed to reduce the amount of time I spend on learning, and I have increased the amount of time I've spent on application level stuff. So I don't like reading a lot of books. I like building software. I like building software a lot, and I like selling software a lot more than I like building software. So that's something that I really focus on. So being a lazy engineer, you need to do that. You need to stop reading books, and you need to start getting into creating software and putting your stuff to application. But you know what? I'll tell you how you can do everything while also being a lazy engineer. So, okay, a little about me and the companies that I've worked in. These are some of the companies that I've worked in the past. Top first, it's Foxmilla, and the bottom right is actually the parent company of Foxmilla. So here I was working with educational technology startup. So we were creating a lot of data analytics pipelines for marketing teams, for operations teams, and things like that. And also I was creating websites that used to track user data, and by tracking user data, it would use to predict what was going to happen and what that person was going to buy in the future, and things type of things he's probably interested in. Okay, that's something that I worked in these two companies. The second company on the right is Zozode. This company is basically partners, and actually one of the core partner company with Flipkart and Amazon. Here I used to work on the discounting system, how to create systems that automatically discount the products that you're buying on Amazon and Flipkart. This company manages that on a backend level. Excuse me. So when I worked in Zozode, I got to understand that okay, some things that I have studied in the past, they're very bookish knowledge. But actually, when you see how companies like Flipkart and Amazon are working in the background, you get to understand that I am inside a well and there's an entire ocean outside. Okay, so you need to get a hold of the perspective that you are in right now. If you are in college and you think that you know ML and AI and you can pretty much nail almost anything, you need to get to know these companies, man. You work there once and you will understand that wow, there's a big world outside this. And I think that will happen eventually for everyone. And the last company which I'm working in currently right now, it's Deloitte. I work there as a data analyst, hopefully converting myself soon to a machine learning background, but for now I am more than enough on statistical analysis and things like that. Okay, so let's go. How do you proceed from here? Let's just consider a small question. So if there is someone in the private chat, can someone put a question? It's the in the private chat, or that where you say that how many of you are from first year, second year, third year, fourth year? Just type a 1, 2, or 3, or 4 in the chat so I can know. So I'm actually looking at your YouTube chat right now. It's on my phone. So I'm more than I'm watching everything. So if you are from first, second year, third year, so I just let me know. Second year, third year. Even in the private chats, you can let me know. Second. Okay. Second. Okay. So mostly are you guys from second year? That's a great thing, honestly, because from you guys are at the similar position as I was. So I started my entire machine learning journey in second year itself. Okay, and so let's just go about how do you start machine learning so that you can actually prepare yourself for that next step, which I'm going to tell you about. Where do you start from? I hope everyone here knows mathematics from 11th and 12th grade. Okay, because that is going to play a major part in what you're going to write and what you're going to understand. Okay, so what I mean by the mathematics of 11th and 12th grade, I'm talking about differential calculus and integral calculus. And I know what you're going to tell me. Calculus. Not again. Abhi abhi to school khatam hua tha. That's something that I also thought when I started doing machine learning, that I do not want to go back to the days where I was studying for JEE mains. That was tough as it is. I do not want to repeat that again. But this is the fun calculus. This is not the JEE mains calculus. Okay, this calculus, you can see your results happening right in front of your eyes. You are not calculating just areas, even though that is a part of things. You're not calculating area under the curve, things like that. No, that's not probably your business. Your business is mostly figuring out how a machine is going to learn by itself. Okay, that's your business. And how do you do that? Okay, so let's jump back 2 steps, because before we understand how machines learn them by themselves, you need to understand what goes behind those creating those machines. So first of all, what I would recommend you guys is to go through a course called Introduction to AI. I think it's by Andrew Yang. Okay, it's either Introduction to AI or something like that. Okay, I'll give you the link to the course and everything. It's free on YouTube and it's paid on Coursera if you ever want a certificate. Okay, so if you want a certificate, I'll definitely let you know how you can go about and get that certificate. It's all mathematics, but I would prefer that you start reading it for free, understand it, and then go for a certificate so that you can ace that certificate and get a very good score on that. Okay, so what does this course talk about? This course is going to basically talk about the mathematics that is involved, only the mathematics. You will not be coding a lot, even though you will be coding a little, where you're coding things like gradient descent, things like maybe a k nearest neighbor or statistical algorithms. Okay, but the thing best about this course is it actually tells you the bare minimum basics of machine learning that companies use till this day. Okay, so you will learn machine learning if you have that elective in fourth year, but I did it in second year for the sole purpose that I wanted to do an internship which was related to artificial intelligence. I did not want to do an internship that was related to web development because at that time I found that web development is something easy and anybody could do it. I wanted to do something hatke. Because I was like one of those Enigma type people that think of themselves as those cool students in second year, that I'll do the toughest technology and become the coolest dude in the class. It does not work that way, but at the same time, I did learn the toughest technology, so it's fine. Okay, so let's get to that course. So some things that you will need to do before you appear for an interview is learn basic differentiation of some polynomials, differentiation of some multinomials, things like that. Okay, and after you have done that differentiation and entire concept, you need to get to graphs as in plotting how a curve of 10 dimensions would look like in 2 dimensions. There are ways to do it. That's something that I found very weird. Initially, when you are in 12th grade, you think like, yeah, there are 3 dimensions. We work in 3 dimensions. Everything is in 3 dimensions. And then you enter the realm of artificial intelligence and you find out that there are 25 dimensions to any problem. Sometimes if you look at satellite images, there are more than 50 dimensions. And now your entire problem becomes like, I, I can't visualize 4 dimensions. How am I going to visualize 50 dimensions? That's going to be a nightmare for me. I can't even think about that because human mind is not made for that. But even if you don't think about the visualization of things, you can always think about the mathematics of things. That's why I always focus on not looking on graphs when you have a multi-dimensional problem. An example of a multi-dimensional problem could be, let's just say, a person getting diabetes. So you might think if a person is obese, he will get diabetes. But we have also seen people who are thin getting diabetes. So there's something wrong. Okay. Then you find out that no, there's genetic disorder as well that will make you cause diabetes. We have also found people who are thin and do not have genetic disorder getting diabetes. How is that happening? Then you find out that there is some poisonous substance. So the more you look into it, the more you find out that there are so many factors that a problem depends on. How do you tackle all these factors and still get a legit result that is going to tell you what's going to happen? That's where machine learning comes in. When you don't know, when you absolutely don't know, you cannot write it on formula. So like you can write it on formula. What's the height of a binary tree? Right? It's log n plus log base to n plus 1. Okay, but you cannot write a formula for when a person is going to get diabetes. That is probably not possible. If there are 50 variables, that's like maybe A1, A2, A3, A4. If there was 50 variables, how are you going to write a formula in 50 variables and then tell me that, yeah, these 50 variables, if you write this formula and you put those values of 50, you're going to get the answer. You can't write that. So you can't even derive that. The only way to derive that is to leave this thinking to the system. And that thinking is done through differential calculus. So you put the data, you need a large amount of data, you put that data, you give the machine the algorithm, I'm not getting very deep into the algorithm because it can get very mathematical. I'll tell you which algorithms to learn maybe. So you put in the data, you tell the algorithm, hey man, start learning. And then you leave that machine for a while because machines take time to learn, just like us. The thing is, we take 12 years to learn a single concept, a very complicated concept. They might just do it in 1 hour. And that's the benefit of using artificial intelligence and why people are afraid of it. Because what took us 20 years to figure out, it's taking them 20 minutes or maybe 20 hours to figure out. And thus people think like, yeah, maybe artificial intelligence will take over. But honestly, I think it's different. I do not think artificial intelligence will ever take over because there are some reasons for it. I'll tell you at the end if I have some time left. Okay, so what's next? You have done your differentiation revision. You have opened your 12th standard book reluctantly. You sat through it. You read everything. Maybe you actually memorized some stuff as well. And now what? You start watching those videos that I've told you about. And it will start teaching you about the basic of machine learning, which is gradient descent. You get that gradient descent, then you move to a little bit tougher things like linear regression. Then linear regression will solve the problem where you need to solve the regression problem. The regression problem is basically I have 10 values and I need to predict what the 11th value will be on a scale from 0 to 100 or maybe 0 to 1 million or something like that. The regression problem is used in stock markets very usually, where somebody would use the algorithm to figure out, okay, what will be the value of stock tomorrow? Okay, so that's something where regression problems come into. And linear regression is not just the algorithm. Linear regression is probably one of the oldest and simplest algorithms, but there are several other. And then there's either a regression problem and there's a classical, classification problem. Okay, a classification problem is going to tell you either yes or no, or maybe a something like a category. So the earlier diabetes problem that I was talking about, it's basically a classical classification problem where the machine is going to tell you, okay, this person has diabetes, this person does not have diabetes, chill, no issues. That's something that you can learn, and after that they will actually push you through the stratosphere and start teaching statistical algorithms, because there is no machine learning engineer without statistics. People think that they can jump over the statistical part because machine learning sounds so cool, but I just think that machine learning is statistics with extra, icing on the cake, things like that. It's machine learning is basically statistics. If you're good with statistics, you're good. You probably can become a great machine learning engineer. Okay, so sort out your calculus, sort out your statistics. After that, approach machine learning. And even if you aren't very good at everything in calculus and everything in statistics, start small. The course that I'm going to talk about, that I have been talking about, it basically talks about very simple topics like normal distribution, differential calculus of single variable, not even double variable. Other than that, it will talk about things like edge testing, chi testing, and these all topics are taught to you in second year, third year. So if you are from second and third year, you guys are going to have a great time because this is in your syllabus. If you look at the second year syllabus for most colleges, you have calculus 2 and calculus 3. Calculus 2 and calculus 3 are going to form the mid-level foundation for your entire machine learning. So if you are good with 12 standard calculus and you're good with second year calculus, you're good. You are more than good to start a good level of software and machine learning and things like that. Okay, so that's something that you should go for calculus, go for statistics, and then approach machine learning. Because don't make the mistake that I made. I started learning machine learning in second year January, and then I had wasted by 1 month, and then I understood, okay, something is wrong. I'm not understanding 80% of the things. There is some gap somewhere. So I went back to my 12th standard books. I downloaded them from online, and then I just studied. I'm like, okay, I forgot the formulas, that's it. And then I just rememorized those formulas and I started applying them by myself. And then I found, okay, it's not that tough. Even the toughest concepts like neural networks, some of the tougher concepts like neural networks, if you solve it by hand, you solve the entire formula by hand, you do the differentiation, you do the calculation, everything, you're good. Any neural network that comes after that is just a modification on that term. And that's why I suggest you to go for the Stanford Introduction to AI course. I'll send you the link. Don't worry. at the end of this core webinar, I'll send you the link and everything. Is there a buffer? Is there a buffer? I hope there's not. I hope there's not. Okay. So the next thing, you're done with calculus, you're done with statistics. Now I want to do more. Once you're done with this course, they will teach you some algorithms. I'll just tell you the overview of what they're teaching you. They'll teach you linear regression, logistic regression, support vector machines, k nearest neighbors, and neural networks. Okay. Oh, it's from your side, no issues. Okay. Now, once you have learned these 5 to 6 algorithms, you are good. The next step that you do is going to be in the direction of internships. Now, what I did was I was very clear about I wanted an internship, and I think the best time to look for an internship is March and April. March and April, and just in November, because the January internships open in November and December, and the June and May internships open in March and April. So that's something that I would recommend you guys to start looking for your internships in maybe a month from now, maybe 2 months from now. And it's not that far, and you can do the entire syllabus in that time. So, okay, so once you have done that, look for internships. These internships should not be something stupid. There are a lot of companies on Intern, Shala, LinkedIn that are going to make use of you. They're going to put you through rigorous data cleaning activities, rigorous data entry activities, and they will call you an analyst. They will call you something like a fancy name or something. But at the same time, that is absolutely not machine learning is all about. Absolutely not. So when I went for my internship, okay, I was doing research. I was doing research in machine learning. Okay, and being the lazy engineer I am, I chose the topic for my research, which would in the future help me make more money than usual. Okay, so I was like, if I'm doing an unpaid internship, it was unpaid because I spent 16K on that trip and I got in return 6K from the company, which is fine. But at the same time, I was like, this is more or less unpaid. I'm paying more than I'm getting. I might as well make use of this skill to make money in the future and maybe go somewhere else from there. So what I did, I started working on time series analysis, because time series analysis is one domain that, which is, I mean, you find it everywhere. Starting from financial sector, you look at the time series that you find on these stock trading apps, that's time series. You look at MRI data, that is time series. MRI data is the hospital data. If you look at sports data, that is also time series. Most of the things, if your performance at a certain criteria is dependent upon time, that's a time series problem. Okay, if there is a pattern in your movement, the pattern in which you are moving over a period of time, that's a time series problem. And it's one of the better things that you need to learn if you're going for going for a machine learning path. You need to make sure that you're choosing the right things. So if you look at the paths that you can take, there is definitely CV, which is computer vision. There is video and image analysis, which is a part of computer vision, but at the same time, it is a little different. Okay. Then there is some abstract stuff related to image processing and things like that, which Adobe Photoshop does a lot. So if you have ever seen these applications that are on your phone and they get famous from time to time, these applications will start off, they'll take your image, they will edit it, and they will make it look amazing. That's done through ML, that's done through AI. How does a machine know what is beautiful? Okay, so beauty is subjective. I'm saying everyone is beautiful, but how does a machine know it's beautiful? It will just take 10,000 images from Hollywood, Bollywood, and other places, and that are considered to be beautiful. It will find out the common features among all those faces and try to build your face according to those 10,000 images. That's something how machine learning works, and that's why I say if you're going for machine learning, you need to think about the feasibility of things. Just because you want to create a machine learning algorithm, that does not mean you can create a machine learning algorithm. You need to see if it is actually legally available or not. There are things that you cannot do. There is a lot of data that is illegal, like user data from Facebook. It is not legally sold. But if you want to build an advertisement recommendation platform or advertisement recommendation system, you need that kind of data. So you need to collect it by yourself. You cannot ask someone for that data because they're not going to give you, because it's illegal to share that data. So that's something that happens in machine learning a lot, where you have so many great ideas, but a lot of that thing that a lot of that algorithm that algorithm requires is illegal. So you just leave it, move on, think of a different way how to approach it. So anyway, getting back to the topic, computer vision is one way where you can go. There are branches for computer vision where you can go. Next is the financial sector, where you can go for time series analysis and things like that. And if you go for time series analysis, you're going to make a lot of money on stock market if you can make some sense out of it. Algorithm trading, that's a big thing right now. Crypto trading using algorithms. You might have seen some people investing and taking out their money within fractions of a second. That's done through algorithms. The algorithm will put in their money. So they tell the algorithm, they give the algorithm some money, and they're like, make me $100 of profit. I do not care what you do in the next 10 hours. So what it will do, it will find out those stocks which are rising very quickly for a short period of time. It will enter that money. As soon as it rises by 10%, it will take it out. And then it will repeat the same process for 10 different stocks. And now you have $100 extra. That's it. You're done. You're good. And then that algorithm will be like, okay, this is the profit that I've made. This is the cut that I'm going to take, and I'm going to give it to my creator. So if you create an algorithm or a website that creates all of this stuff, and it does it for free, and it does after some charge, you can make a lot of money by just doing some time series analysis using a little bit of mathematics. You're good. You can make a decent amount of money by just this. Bloomberg makes a lot of money by this. Most of these investment banking, even though there are a lot of investment bankers who are actively trading large amounts of money, but there's a lot of machine learning algorithms that are working on just trading patterns and working on them, and they're making a lot of money from there as well. So you can go for fintech as well. Then there is healthcare data, which is one of the startups that I built in the past, where you are working on data such as mental health. So my startup usually worked on data that was related to depression and finding when a person is getting suicidal or he's having depressive thoughts and things like that. So my algorithms used to predict this week is going bad, the next week might even go worse, depending upon these disease scenarios, and therefore these are the things that you should do to avoid them. So I used to predict if a person is going to have a bad day or not, and then I used to tell them how you can avoid having a bad day. And that's something very similar, but at the same time it was so new that the investors thought that it was great, and they actually started investing in it. And it's a very simple algorithm if you actually think about it. I'm not telling the algorithm, of course, but yeah. And after healthcare data is not just mental health related, it's also physical health related. So a good example of a good physical health related data could be X-rays or MRI images or diabetic retinopathy. So when people have diabetes, they do go blind sometimes, which is a very sad thing to happen. But if you use the right algorithms, you can actually prevent people from going blind by predicting that they're going blind right now at a very early stage. So if I predict 10 years from now that you will go blind, I can probably stop you from going blind. And that's a great thing to have. It's a great system to create. And maybe someday people will never go blind from diabetes, just because we're predicting that before 10 years before it actually happens. And that's a great thing to do. So now you know where you can go. You need to figure out which domain actually fits you, work hard towards that domain. If you're a very finance related guy like me, I love finance. I love things that are very fast moving time series data. Go for finance. If you think that you want to make a medical impact, go learn those algorithms. What you need to learn for those algorithms, that you will find out only after you have find out which domain you like working in. So giving you an example of one of my friends who works at Goldman Sachs, he used to love working on image based data, regardless of how and where it's used. But one of my other so he used to create anything related to image based data. He used to create systems that would predict how a person would look in 10 years. he used to create a system that would predict if a car's tire lifeline is actually fading out, but just while looking at it through the image. So that is going to save you a lot of money, considering tires cost a lot. If I can just click an image of a tire and then figure out, yeah, my tires are about to burst, I might as well just get them repaired rather than buying a new tire. That's good amount of money saved, man. So that's something that you find out what you like, think, and then start working on it. But yeah, if you are appearing at a college level or even at an interview level, there are some prerequisites that these interviewers are going to expect you to have regardless of what domain you have specialized in. Some of these requirements, as I have mentioned before, are going to be calculus. They're going to ask you, you cannot avoid it. It is fine. Never mind. Second thing is going to be a little bit of statistics. And the third is going to be the basic algorithm, the bare minimum basic algorithms that the course is going to teach you. Okay. So now that I have spoken for so long, I would like to throw in a quiz, and maybe I would like to get to know what the background of you guys is, and maybe from there you will understand what I'm talking about. Like, the thing is, like, when you are in second and third year and you see all of these people doing all this competitive programming, doing so well in these hackathons, you feel that you're getting left behind. I need to do better. I need to do this. I need to do that. I'm trying to show you if it's actually the scenario or not. So considering the amount of people we have here, I am sharing you a link right now in the private chat. I hope you can share it to everyone. And you guys can go ahead and click on this link and start filling that form. And I can actually show you guys if it's actually, the scenario, what you think it is. So I hope you guys have shared the link that I have sent. So you guys just go in and I'll tell you, like, and why am I talking about DSA? You'll get to know very, 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 very soon. Now I'm getting actually into the application level of things. So I actually need to know what you guys are, what level you're at, and from there maybe we can move. Okay. I like how most, like, two people have said that I'm decent but not amazing. Okay, so most people want to get into data science. Great. Okay, Android and data science. Decent but not amazing. Okay. So I do get a rough idea that people are decent enough at DSA. That's good to know, actually. At least there is no person in that one category that is on the right. ये coding क्या होता है भाई? But yeah, that's not an issue. Okay, so how do you get into the implementation part? So many people think like, okay, now I'm going for machine learning. I'm trying to transition there. The first thing that I need to do is learn Python. Probably not. The things that I have mentioned before in the past, they are much, much, much more important than you learning Python. But once you have done those, definitely go for Python. Once you have started Python, think about this. Most of the algorithms that are in machine learning, they are O of n cube, or maybe sometimes more than that. Okay, sometimes it's O of n4 or n to the power 4, or O of n to the power 5. It even gets to there, like it's O of n to the power 5, where for every input you are doing n to the power 5 calculations. It is extremely, intensive task. CPU intensive, and graphical processing unit intensive. But you can decrease that. You can decrease it by a lot as long as you know DSA, and that's something that the machine learning industry solely and desperately needs. better implementation of common algorithms. If you can implement a currently working algorithm that is taking a day to process and bring it down to 12 hours, you are going to make in millions of dollars. Okay, so that's something that's why I asked you guys about how good is your DSA. Are you even like working decently at it? Because believe it or not, in some of these in job interviews they will ask you DSA at some point of the time, like not a very tough DSA, but yeah, bare minimum DSA. Or they can just ask you to implement gradient descent, which is an algorithm in itself and also a part of DSA. If you can implement that, amazing. If you can't, that's an issue. So just because you're learning statistics and calculus and machine learning and all these fancy algorithms, do not feel that you are free from DSA. Learn DSA. Once you have learned that, that's the point where you start applying to companies. Okay, I am not telling you need to be a genius at DSA and getting CodeChef rank 5 or whatever. They have those systems, right? I'm not telling you to go there. More like you need to be able to solve bare minimum basic interview level problems. That's it. Okay, do that, do some calculus, do some statistics, and maybe then we can move forward from there and sit for interviews. Okay, focus on this strategy. Believe in the process, and results are ought to come. Okay, the strategy remains the same. If you are trying to transition, the first thing that you should do calculus, second thing statistics, third thing the video that I'm going to share with you on the chat, and the fourth thing definitely would be DSA. Once you are done with these four things, you are good. You're good. You can actually start applying, and these applications are going to look at a few things. They are going to the application. I'm not even talking about you sitting for the interview. I'm just talking about your resume. If you are applying for a machine learning role, they are going to look for a few things. First thing first, they're going to look for some data analytics background. Contrary to popular belief, people who get into ML, they do not start with ML, they start with analytics. Once they have done analytics to a great level, they are going to shift you to a point where you can actually start implementing simpler algorithms. And once you are good with simpler algorithms, they're going to put you on actual machine learning algorithms. Once that is done, you're good. After that, it's all a game about your creativity. If you can find a problem and you can create a machine learning solution to it, you can make money. That's it. From there, it's just about your creativity and where you can apply your machine learning skills. Okay, so I have asked the quiz, so there's no quiz time. So do not care about the languages, because I have found that some people prefer R, some people prefer Python, some people prefer Julia. Julia is an upcoming language, and if you are a Node.js or a JavaScript guy, there is TensorFlow for JS as well. You can do machine learning in Java as well. So do not go for the language, just understand the concepts. The language comes later. Okay, the language can be done within a week. Do not care about it. Now, why have I mentioned all these other technologies? DevOps, Burn, Flutter, Java, React, whatever. In your resume, they're going to look for implementations of these programs. Okay, these algorithms and machine learning algorithms. And if these implementations are satisfactory, that is more than enough for you to get that amazing job. What do I mean by implementation? It is not just a Python program. So suppose you have created this algorithm that predicts if you have cancer or not. Amazing algorithm. But I know the results from it. I can probably read a research paper, but at the same time, do you think an HR has a time to read a research paper? Probably not. Do you think the HR has the time to understand what your algorithm does at the technical level? Probably not. Do you think the HR is going to relate your problem to the problem statement that the company is actually working on right now and think that you're an eligible candidate? Maybe not. So my entire thing revolves around, once you have created these algorithms, find your friends who are good at creating either websites or Android applications and connect your algorithm to these applications and websites. And once these websites and applications go live, you can send these websites and applications, you can write these definitely on your resume. And once that person creates this application and then actually it's live on the Play Store, it's going to create a large impact. Instead of you just showing that, see, I wrote this 10 lines of Python code, it does this, it does that, I'm hoping that you take me as a data analyst. Probably no. But if you show me that, see, this is a website that does the job that you guys have been looking for in the past, and this application is just the mobile version for it, so you can use it anywhere, and this algorithm is exactly what you're looking for, and it's done in machine learning, it uses this, it uses that, and you market your product very well, there is a very high chance that you're going to get selected. Because uh, knowing the tech and knowing the marketing for it as well lands you in a very comfortable position, where even though if you are not chosen by the company, you are more than sufficient to create software and sell them by yourself. Okay, so that's the point you need to reach. You need to reach a point where you can actually create machine learning algorithms by following the statistical patterns. You need to make sure that the results that I'm getting from this machine learning algorithms actually make sense, and then at the end need to create a platform where people other than your friends can access it. Your friends can probably access your GitHub account and then download that code and run it on their systems and then think like, okay, this guy has been working on something. 99% of the people on this earth do not have that kind of time or do not have that kind of experience to do that. Until and unless you put it on a website and you put it on an application, it's not going to work out for you. So create applications, create websites after you are done with your data science work. You don't need to do it by yourself. You can definitely get your friends to do it for you and then make it a joint project from your side and then put it on your resume. That's the smart move to make. And once that is done, you're good. Sit for your interview, sit for anything. And I think once you do that, any company will take you. Barclays, EY, Deloitte, anyone. So if you have any questions, feel free to post them. Feel free to post them in the comment section and everything. And I'll be taking questions from now. And I'll also be sending you guys the links that is necessary. So feel free to send in the questions. And I'm looking at private chats as well, so don't worry. Okay, what was the name of that guy? Okay. So this is the first video. Okay, though. This is the first video of this playlist. I hope you guys, coordinator, do share it with students. This is the video that I'm talking about. You need to start with this video and then actually move forward from here. And this one is free, right? This one is totally free. I used to study from these videos all the time. It actually helps a lot. This is the start. This is the first video, definitely. There's a playlist for it. If you actually just search it, you will find the playlist and you're good to go. Can you help me in making recommendation systems for food ordering systems? I do not code for people, as like I stopped doing that. I just code for my company right now. But yeah, if you have any doubts about the recommendation system, I can maybe clear that out. If you want to know what you need to use, what kind of data you have, what kind of things you have, maybe I can help you out with that. You need guidance regarding that. Okay. So let's just start with the basics. What are you creating the recommendation system for? What are you recommending basically? Food ordering. No, I'm not sharing my email or WhatsApp. You can contact me on LinkedIn. I'll share my LinkedIn account. Okay, so you're recommending food. Great. So you're recommending food based on what? So I'm actually telling you the live process of how to approach a machine learning problem that might help you. So what are you recommending the food based on? I have posted my LinkedIn account, guys. So if you want, you can post it there in the chat. Okay, taking too much time, man. Okay, so let's just take an example of how you can recommend food just from the top of my head. First of all, find who your customer is and where he is from. Okay, if he's from a single city, you need to categorize that person into categorize your customers into sections. So based on collaborative approach. Okay, collaborative approach, you need to expand on that because there are several collaborative approaches. Okay, so I'll just tell you an example of how you can approach it. If you are doing it within a city, you need to figure out through frequency analysis on which food items are closely bought together and on which points of the year certain food items are eaten. Let's go for an example. If you live in a city which is dominated by, let's say, Bengali people. Okay, so Durga Puja is coming soon. So there is a very certain kind of food that is eaten during this festival seasons and things like that. And you need to have the kind of data for this. So what I would recommend you to is get the data from either Zomato. So Zomato has its data free online, some parts of it, and you can, based on that data and based on the festival data, you can figure out in what festivals what kind of food is eaten, and then start recommending those to people that you find that might be potential customers. Okay, you can do that based on surname categorization, or you can just do that on locality based categorization, because we have already found that people of a singular community usually live in groups. If you find a person living in a group or community that usually coincides with the type of food that you're trying to provide them, you might want to recommend them that food item. Okay, so that's something that you would like to approach. So a locality based approach or maybe a time series based approach might be the way to go in the first few days. Once you have gathered a decent amount of data, about how people actually surf through your application, how people see food items in your application, maybe Swiggy or something, maybe then you can go for the frequency analysis, where you find out that, okay, whenever a person buys a gulab jamun, a person is also going to buy a laddu. That is just from the frequency analysis, and that's also a recommendation system, and this is all in the statistical domain. I haven't even entered machine learning yet. When you enter machine learning realm, you need to have some level of abstract input. This abstract input can come from anywhere, and I'll leave that to you. But some of this abstract input, the example of this could be uh, inputs from Instagram or Facebook, where they're actually telling you their feed, their scrolling patterns and things like that. Your scrolling pattern actually tells you a lot about what you are thinking about and what you want to eat and things like that, right? So that's something that I would recommend, to gather different kinds of data and create different kinds of models, and then approach the problem of recommendation instead of just creating one machine learning model and trying to fit that for everyone. If you're actually serious about it, if you just want to create one machine learning algorithm model that solves some parts of your problem, go for it. But if you are actually thinking about creating an application that sells and actually makes an impact and becomes the next maybe Swiggy, so you need to think about it in a very wide manner instead of just looking down the pipe hole and going for single algorithms. You need to look at several algorithms. And also, I'm happy that you are very item based collaborative approach. Okay, item based, maybe frequency analysis will help you. If not, a clustering based analysis will definitely help you. So you might want to look into clustering. It's your college project. Look into clustering and hypothesis testing. Once you are good with that and verification of clusters, you're good. You can create almost any kind of collaborative and item-based collaborative systems. It's very easy from there, honestly. You can there are a few video channels where you can follow. So for my preparation, I usually follow Krishnak. Maybe you can follow him. Krishnak is a YouTuber on, so of course he's a YouTuber, and he talks about anything about ML, anything that is related to artificial intelligence. He's talking about. So maybe that's some place that you want to start with, and maybe you can go from there. Okay, so if you have any questions, I am more than willing to answer. Also, do have the goal in mind, right? As I said, that you need to have an affixation for that I want to do this because I find this very interesting, but at the same time you need to have the thing like, why am I doing this? For me, it was PlayStation, because my parents said that I'm not going to buy a PlayStation. I was like, fine, I'll do it myself. I'll create software by my own and I'll sell it to businessmen. And I did that and I bought my PlayStation. So you need to have a very fixed goal that I am going to create software to do that. I'm going to create software to do this. For some people, it is like, I want to create software because I want to create my own business. There are some people like that. And some people are like, I want to create a machine learning software because it's my school project, like you. So you need to figure out in which category you lie in. For me, it was always about buying things that I could not usually afford because my some or the other reason. So I used to think like, okay, if I cannot afford it right now, how can I afford it maybe 1 month from now? And then I would create software that would actually sell. And that's the way I learned machine learning. So I used to think of a problem and then I used to think, like, how will I solve this problem? Let's Google that. Then I used to Google it, and then it used to take me to Kaggle. So Kaggle is a great place to learn all of these things. And that's something that people will definitely look at. And maybe that's something that I actually glossed over. But the thing is, whenever you approach an interview beyond your project, if you don't have very great projects, they're going to look at your Kaggle profile, if you have won any competitions. So I participated in competitions in Kaggle before. They were great. I used to stay under 200 rank. So it was a great rank for my time. I was a second year student. But yeah, your Kaggle profile is going to matter a lot. And is going to decide if you actually get the job or not. Because if you look at these LinkedIn job posts, they actually say you need to have an active Kaggle profile. If you have a good Kaggle profile, you're good. You're great. You can start off. But you can start off applying for jobs. But if not, start doing some level of competitions on Kaggle. Okay, so do we have any more questions? Okay, I don't think there are any more questions. So maybe we can conclude this webinar, if that's okay with you guys.
We are very grateful to you for giving your precious time, sir. This session has already proved a splendid learning session for all of us. Thank you all the audience for enjoying this session. Stay tuned, guys, for next upcoming sessions. Thank you so much, sir.
Thank you so much for having me.